Hey everybody, welcome back to Trial and Error. My name is Tom and I would love for you to take a look at my tool. So what we have here is a very unique tool. This was developed and crowdsourced into fruition, which you don't normally see a lot of, especially in established tool industries like this. But people wanted this thing so bad, they not only met their crowdsource or crowdfunding goal, but they blew it away. So this is from YesWelder. It is the Firstess MP200, and you will see very quickly why people wanted this thing enough to proactively invest to get it developed. It encompasses so much in one machine. You never really see a welder and a plasma cutter all in one unit, but that's what you have here. From MIG welding, flux core, TIG welding, stick welding, and plasma cutting, literally all in one box, which ends up saving obviously a whole lot of space, but also a lot of money. And if you're a portable welder or just doing a little side jobs, one unit, one handle, and you can literally do everything most people will ever need to do. So the question obviously is, does it hold up? Because this is a first rendition, new iteration of a brand new product line. I'm guessing it carries over their history with their other welders in terms of really good build quality and product component selection and just overall design. But we're gonna pop it open, take it apart, take a look inside and make sure that's true. And I'm really excited about this one because it is super unique in terms of how it came to be. And it really does, it ticks off pretty much every box. Now, this is gonna be a little bit longer than my average video because this is a very complex machine with a lot of different options, but I did index everything so you can just jump to the section you want, and that way I'm not wasting your time. Wow, that is, it's a lot of equipment. First off, first impression, this thing is gorgeous. It's got a beautiful finish on it. Really like the front panel, just gorgeous, but we're gonna tear into this thing for sure. But the accessories they give you, I didn't expect this to be in the box. I didn't read that this was in the box, and usually when you buy a multi-process machine, more often than not, I would say, you have to buy your TIG torches separately. They include TIG torch and a consumable kit, so you're ready to go right out of the box for that one price. That's huge. That's a $150 accessory just in that bag by itself. Really, really nice. Plasma cutter, same as what they use on their standard plasma cutter for ends, and that's true for actually all the accessories here. There is nothing specific to this machine, which is great, because it's an odd duck because it does so much. I was afraid they were gonna use proprietary accessories that they would force you to have to buy from them. Not that their stuff is bad, actually, I like their handle better on their MIG torch than anything I've ever used before. So nice plasma cutter, with plenty of cord on there too. Love their MIG setup. It uses the Euro connector, so again, very standard. But the gas and the nozzle setup in these, it's all copper or some other metal. There's no plastic in here. And that's uncommon to find at this price point. That's a really, really nice gun. I actually like their guns so much better than just about anything else I've ever used. Got an air line here to go to your compressor for the plasma cutter. Got the 240 volt, 120 volt adapter because yes, this will run on regular 120 volt and it will not only weld, but it will cut plasma on 120 or 240 volts. Ground cable, honestly, not super impressed right out of the box here. And there you go. This is not a shrill review. I'm gonna tell you my honest opinion on it. Cable looks really light for what it is, especially for the amperages this can push. And it's, you know, pretty standard, but chintzy clip on there. That would be something, well, we'll take a closer look at it, but I'm gonna guess that's something we're gonna wanna upgrade. And then your stick welding clamp, they do a nice job. This is no different. Tons of spring action on this thing. It'll hold it nice and solid. So then we got a bag of accessories. So a little bit of pipe tape for the air fittings, hose clamps for those, and then a second wheel for your MIG spool. Also includes a air regulator for the plasma cutter along with a gauge, which is great, and the bracket to mount it straight to the back of the unit. So that's nice. So something YesWelder's been doing recently, they put these little one-pagers in there and I really like them. They've got all of your spec breakdown on welding parameters in terms of what you're welding, thickness, and gives you your settings, which is nice. And then on the other side, they have a near idiot-proof, although nothing's idiot-proof because idiots are too smart, connection guide, depending upon what you're doing, just tells you very clear what connection needs to go where to make that happen. So that's really neat. I really like what they did with the front of this, because this is a potentially complicated thing to set up, but they've really made it simple. So you've got your positive and negative, and you can flip and flop that depending upon what you're welding and what you're using. And then on the far outside and inside here is your pathway for your plasma cutter. And they wouldn't put a spring-loaded door on the plasma torch side because you've got air going through here too, and you don't need dirt and stuff, grime getting in there. And then up top you get your Euro connector for the MIG gun. So really easy to figure out what you need to do here, and minimizes the amount of connections overall. This is what YesWelder has been missing. They have always built a really good welder. However, the setup process and the settings process was always a little less than smooth. This is their first foray into a menu-driven color screen, and I can't wait to play with it. That should make using this thing so much easier, whether you're a professional or this is your first machine. I can't wait to play with that, because really that's been one of the only things I've had to complain about, is that user interface has just been a little awkward to use, and I think they're going to have that dialed in with this one. Now taking a look at the MIG wire feed system here. So they have this same tensioning system. It is quick and easy, not the best in terms of quality, but it works fine. It's just a little bit flimsier than I'd like it to be, but overall it does the job, and I haven't had a problem with the other ones that use this exact same method and tensioning system, so I got no complaints there. I see that they've included their 100% all metal from the drive motor right to your wire drive system, and I love this. This is one of the best ones I've honestly ever seen. Very easy to work with, works perfectly, and no plastic, no gears, nothing to strip and wear, because this takes a lot of abuse over a long period of time. You need a good, reliable, and solid mechanism, and I think we checked this last time. It's all aluminum. Really, really nice. Because this is a flux core capable machine, they do have to give you the option for reversing the polarity, and that's what this is. You would back this screw out, flip this connector over to the negative side if you wanted to go with gasless. Now, in a perfect world, this would be automated with a contactor in the back that would flip polarity, and you'd be able to drive that from the menu. So if that's something that you plan to do a lot of, switching back and forth between gas and gasless, then that's not ideal. But the reality is if you've got gas as an option, you're going to be on gas all the time. And if you have only gasless as an option, you're probably going to be on gasless all the time until you pick up a tank of gas and make the switch. So it's not something you're going to use a lot, but just keep in mind that that is a manual process to flip over. While we're able to see a little bit of the guts here, you'll see thread locker again on all of the fasteners. We've got a nice copper bus connection here. They went really light on this particular cable, but this is just for the plasma, so you're going to max out at 50 amps on that anyway. So if you see that thinner wire and are wondering, hey, that seems pretty light for a welding, it is, but this is just on the plasma end, so it doesn't need to be super high. It's not going up to 200 plus amps like it does on the welding side. I have a feeling when we look at the other side and can see the other connectors, we're going to see cables twice that size feeding those connections. Taking a look at the back of the machine, a couple of different things here. One, most YesWelders will have a 120 volt connection, even though they're 240 or 120, because they're generally smaller portable welders. They know that this machine, a little bit more substantial, it's probably more apt to be set up in a permanent location, so they've gone and put the 240 volt connector on here and then giving you the adapter to change that back down to 120 volts. So that's probably a very smart decision. Little thoughts like that kind of tell you that these guys are actually paying attention, which is really nice. They've also added a twin fan setup that is quieter rather than the one fan screaming. They've done two smaller fans on this unit that is supposedly a quieter operator, so that's great. You've got connections here or posts for the air regulator. Good snap action switch that they seem to use on all of it. Nice switch. You've got your mixed gas coming in for MIG, and then your cut gas, so air, just compressed air, goes in on that connection. So real simple there. While we're looking at it, this is the other side. Freaking beautiful machine. I mean, I can see myself in your pants. I can see myself in that welder. Now Now that I've got it apart and I've had a few minutes to take a look at what's going on here, because there's a whole lot going on here, I'll just kind of walk you through what they've done. So what I do see is they are sharing a capacitor bank for the entire machine. So everything pulls off a core capacitor bank with SanCon caps in the center. It looks like they've got 4 of them, 4 1500s stacked, which should be plenty. So there are 3 different IGBT transformers, step-down transformers here, fed by switching MOSFETs. And some of them are brand name and labeled, and some of them are not. I'm honestly not sure what this bank is doing, but given its location relative to the fan right behind it, obviously it's doing something important. These are a no-name MOSFET or switch. These guys, however, I'm guessing must be the supply for at least the MIG side, because each one of these is a 66 amp. So you're talking 260 plus amps total bank control there. I'm guessing that handles the 200 amp MIG side of the thing, and they've left themselves with plenty of overhead there. And that's part of the reason that you get the run times out of this, which considered a duty cycle basically. So how much runtime straight can it handle before it needs to stop and cool back down? And even at maxed out on this thing, I can't remember what it was at, but it was over, I believe, 50%, but don't quote me on that. I don't have the literature in front of me. But that is plenty. You don't go 100% of the time. So they definitely did oversize at least the power supply side of it. And then they've broken out, or at least what it appears to, the plasma cutter is definitely this bottom section and bottom board. This center main panel it's just handling that incoming AC, converting to DC, and also handling the surge with the capacitor bank for the whole machine. Taking a look at the plasma torch, so we have another MOSFET bank here, IGBT power supply, that is specifically for the plasma cutter. And then you'll see this is a high voltage transformer, so this is what you're always looking for in a plasma cutter. So it's not a scratch start. It basically creates its own ignition source via that coil. Right there are the adjustable contact points for that not scratch start, for that high voltage start, all isolated on its own little board there. And then this is what's up on the ceiling here, which is actually the bottom, is the power supply board for that. We've got feed motors here. So here's something new and pretty interesting. They've actually put a current measuring device with feedback lines back into kind of the main processing board, both for the plasma cutter as well as the TIG and the MIG guns here. Each one of these has a monitored feedback loop for actual output current, which is very interesting because that is not something you normally see. And part of the reason is manufacturers have a long history of overestimating the current output. So they'll take something like the power supply rating and try to use that as the actual output current for their welders to sell at a higher number, essentially, kind of like horsepower in a car. You take it at the crank, not at the wheels when you're a manufacturer, and try to market it as that. Even though that's not really what matters to the end user, it's how much current is coming out of the gun that really matters. So I would tend to think if they're going through the effort and expense of doing active feedback monitoring or current monitoring, that what we see on that screen is probably a little closer to the reality than it would be in another machine that is just essentially got a table in there that it's measuring, all right, where if we're set at this amount on the transformer, it should equate to this amount, and showing you that on the screen. That's a really unique thing to see inside one of these, and I'm pretty happy to see it. As we talked about earlier, you can see the leads that are not part of the plasma. Well, actually, there's a good example right there. So we're back up to probably a 30 millimeter lead power cable coming out of the MIG and TIG board there, instead of just that lighter gauge that we see coming off the plasma cutter, because again, I looked it up in the document, so even at 220 or 240 volts, this is only a 40 amp connection, so it doesn't need to be anything too big, but they did gusset it up where it counts here. on the MIG side where you're really pumping some amperage. As far as just overall, again, it looks really busy because there is a lot going on and a lot of wiring for sure, but everything looks really good. Board work is beautiful, conformally coated on every single board. Every connection has some sort of mitigation for vibration and things popping off. Tons of Celastic on just about everything. It's probably tough to see in frame, but the brain boxery, display driver, all of that's attached just as its own individual unit, and they've done that with just about everything. So it's very modular in that sense, which means it's very easily repairable or replaceable. When you do have a problem, you don't have to rip the entire machine apart, so that's good. And in worst case, if you couldn't replace just a component and you needed to replace a board, obviously there's probably 7 different PC boards in here, and you could easily just swap those out, so that's great. But really nice work on all of that. They've clamped the gas line. They did not clamp the air line. That's just on with a barbed connection. It would have been great to see a clamp on that, but thought out, well executed. A mixture of name brand and non-name brand stuff. There's definitely half and half in here. But everything looks really well done, really well assembled, right in line with everything else that they've been producing with the rest of their welding and plasma cutting lines. So there is one other thing I'm not seeing in here that I would have liked to see, and that is a high voltage start for TIG. So I'm guessing, just because I haven't seen it, I'm guessing that this is a lift TIG or a scratch start TIG. They'll call it lift TIG, but really most of the time you've got to get your TIG torch basically on the material, so it's more like a scratch start. And that, I mean, they've put so much into here to add that feature. We're talking another little board about this big. And not a whole lot of expense. And for those of you that are going to use this for TIGging, or at least a lot of TIGging, that is a really nice feature to have. If you're just going to use it a little bit for TIG here and there, no problem. But if you are planning on buying this as like your main TIGging machine, I would say that is a feature that this is definitely missing, or at least it looks like it's missing, but I haven't checked the documentation yet. And if I'm wrong, I'll make sure I add that back in at the end of the video. For MIG setup, we're going to grab the MIG bag. I like how they've just kind of put everything in separate bags. Makes it pretty easy. And again, love this gun. It's just the most perfect ergonomic gun. It's got a super light trigger on it, which I really like. And then most importantly, this nozzle setup is pretty slick. So a lot of the off-brands you will find this piece here is actually made out of plastic, and they crack and get brittle, and this is what basically lets your gas pass through and around, and these all break apart over time. Very nicely done here, though. Everything is metal or brass, or I mean, this is copper coated. I doubt that this is actually copper, but copper coated just to keep welding slag from getting built up on it. So Euro connector on this, love them, plug and play. Obviously all brass on this too, really nice. Ground cable. Yeah, not impressed. I can tell from just the weight of it alone that it is aluminum, so I'm not even gonna bother cutting into it. There's no way that's anything but aluminum. It's just way too light. And the gauge is, I mean, again, I'm sure it's rated for that, but it is definitely thin jacketed. You know, upgrading this would probably be on my short list. Just for comparison purposes, this is my ground cable, what I like to use versus which, and again, this isn't far off from what you get out of the box, but a good ground cable is so super important to getting a good connection and a good weld. So I always this is actually a 2-watt cable. You're not going to find this on any machine unless you're spending $5,000–6,000. But this is a worthy thing, and you can make these up yourself pretty easily. So you can buy the ends on both ends, and that's actually what I did with this one. I made this cable up, and I do recommend that. So we are going to do gas MIG, so we're going to connect this to our negative. Upgraded rubber hose for the gas line. For the air line, they give you just like that nylon reinforced rubber, or not even rubber, vinyl. But they do give you a nice hose for the gas, so that's great. I'm loading up a 10-pound spool of 035 MIG wire. You can use a 1-pound spool on here as well. You just back off this nut and spring assembly, and it comes down to a slimmer peg there that the 1 pound spool will fit right on. Put a little 45-degree cut on that. We'll feed it into the spring, release that mechanism over the roller, and into your home. And I'll punch it through until I know I'm firmly in the line that goes to the gun, so I don't have to worry about it getting caught. Lock it down. So we're going to check tension just by pulling this back. And you can see obviously we're rolling this assembly, which is what you want. Yes, you can do this too tightly. You don't want this super tight. You want it tight enough to grab, but you don't want it locked down so that if you end up arc welding the tip of your MIG wire to the tip of the MIG wire gun itself, and it kind of jams up there, you don't want this thing being able to just keep packing welding wire down into your cord, because that's how you end up getting it all jammed up, and that is not a fun thing to untangle. And in a lot of cases, you can't get it out once it's in there. So you do want to have tension on this, but not too much tension. If there's a problem with the tip, you want this to be able to slip freely and not force wire down the tube. So this is the moment I've been waiting for, and it's not just because it's cool to have a color screen on a welder. The interface is what you use daily, especially on a multi-process machine where you're doing a lot of different things. This makes such a difference at your speed and confidence when you're using the equipment. So I can't wait to see what this thing can do. Damn! Wow, that's a really nice screen. Okay, so we can hit the home button here. By the way, I am showing you this exactly as I learn it. I have not turned this thing on. This is the first time we're looking at anything, which I always find interesting, because if I stumble around with it, chances are you probably will too. Probably less than I will, but... Okay. Well, that's freaking simple. MIG. Gasless MIG. Lift TIG. Plasma cut. And settings. This one feature may have just made this my new welder, replacing the ones that I'm currently using, and my plasma cutter for that matter. You can select between metric or half-ass backwards inch standards, so that all of the settings are in a language you can understand without having to cross-reference. I am loving that. Change to English. Select. Success. Yep. This is my new toy. That's a keeper. All right. Menu, I guess? Yeah. So we're going to head over to MIG with gas. Hit select. Oh, cool. Okay. What's this do? So this knob is letting me adjust the amperage, and it's compensating that with voltage, which is related obviously to the amperage, so it's adjusting those two. But it looks like, yeah, and then I can compensate higher or lower on voltage without adjusting the amperage. So that's really nice, within a limit, obviously. Let's see what it does. So up to 5 volts up, and I would imagine 5 volts back down. You can adjust that for fine tuning, but you'll usually just be able to dial in the amperage you want. It is adjusting the feet per minute of feed speed on the weld wire. How do I get up there? Ah, there we go. All right, so gas selection, 100% CO2, mix of argon and CO2 at 75-25, 80 and 20, and 100% argon. I'm gonna go with 80-20, I think that's what I've got. No, I think I got 75-25. Either way, it's not gonna make a huge difference if I'm off 5%. All right, we got our spool. You can select between steel and stainless steel for your spool, and then your diameter. This is so friggin' easy. Trigger mode, 2T and 4T. Press and hold it, it welds, let off, it stops. 4T, tap it, it welds until you tap it again. I'm gonna keep it in 2T. Here we can, I would imagine, get our settings based on material. Yep, material thickness. So you'll see it's adjusting the amperage based on the material thickness. And it goes right down to 18 gauge. Wow, that's neat. All right, so at 18 gauge, just 20 amps, all the way up to a 1/2 inch of material. Oh, I love this. I love it already. We've got burn back, so measure of seconds. And memory. So I did read up, you can set your favorite settings. So if you're doing projects, especially repeatable projects with a lot of the same materials, you can actually program into this your favorite settings for those materials and save them in the unit so you don't have to go back through and reset it every time. And you can do that in each of the different modes that this thing can cut in or weld in. So really cool feature there. Again, like you wouldn't be able to get that without adding the screen. So the screen is not, it's not just for looking pretty. It actually has some really good functions and features. All right, so your cutoff voltage on the bottom end is at 20 amps. I would have liked to see that go down to 10 amps. It's tricky to weld at 10 amps on MIG, but certain situations in super thin material, sheet metal, that is a nice feature to have that lower unit, that lower end cutoff. But 20 amps, you'll be there. You just may have to tap, 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 tap before you blow through material. I was just trying to load the spool of MIG wire through, and I was about to start complaining about them not having a dedicated button for that. But you just press and hold this when you're in the MIG mode, and it just starts feeding the line. So they really have seemingly thought of everything here. Easy as that. I'm just gonna throw a little bead on top of this 1/4 inch just to get an idea, make sure I did everything right. And then we'll try some nicer welds. There we go. All right, so we are dealing with a little bit of 3/16, so I've got it set on the warmer side of the 3/16 range. And let's see how she does. I'm gonna just tack this up first. I mean, Jesus, for a first weld, not bad. For our next trick, we're just gonna max this girl out. Put up to 200 amps and let her read on some 1/4 inch. Let's burn through the hole here. No problem. That's what you want to see right there. So one of the ways I like to test power is to take some heavy material like this and you go near an edge, and we just start down here and then we try to burn through that edge just to see what it gets for penetration into thick material. And as you can see here, well, hopefully you can see, it took that 1/4 inch straight on down to the other side here and literally just melted it down into a puddle. So, you know, short of actually putting an amp meter on it and checking that output, frankly, I don't really care what the number is. What I care about is what do we get for good penetration. And you can see this goes a 1/4 inch deep, no problem. It's rated for 1/2 inch, and truth be told, it wouldn't be my first choice to weld something that thick. I'm sure you could do it, but it would take a lot of prep. You'd really want to make sure you miter those angles out, really give yourself a nice gap to weld put your puddle in the center of. But you can see on 1/4 inch material for doing framework, I mean, no problems there at all. Plenty of heat, plenty of power there. In order to get it set up for plasma cutting, we're going to start with the regulator here. Very simple. It's a regulator and air-water separator. So in theory, this will take up any moisture that's in there. You just push the pin to release it. But you do have a specific in and out on this, so we're going to make sure we put the right connections on the right connectione. Ready to get the air pressure set right. So this is the only time where you do need a conversion, but you really only need to do this once. So this is looking for about 62 PSI. That's 62 is kind of in the middle of its range, but they measure this in megapascals. So 62 PSI is 0.427. So we're just gonna dial this guy up by lifting until we get 427, right about there. Put it down to lock it in place, and now I can hear a few air leaks now that I've cranked the pressure up. I'm gonna snug these guys back up. There we go. We'll dig into the plasma cutting bag. All right, here, I'm guessing we're gonna go right there. And then your electrical connection, this is just the switch basically that's on there. While I'm in here, I'm going to disconnect the ground clamp, which is the same ground clamp we use for the welding. I'm just going to relocate that over to this far side. Lock that in place. And we're done. Power it back on. And it does save your features. So every time you shut it off and turn it back on, you don't have to go back through the same setup process. It'll be right back, or it's supposed to be right back into the MIG, which it is on the same settings I left it in. But we're gonna flip on over to the main menu, oops, and go to plasma cutting, select that, and see what we got for settings here. Okay, so this looks like number of seconds for the air to start prior to cutting. So we're going to put that on at just a half a second. Number of seconds for the air to flow after cutting, so that kind of your cool down. We're going to leave that at 1.5 seconds, or I'm going to put that at 1.5 seconds. We've got trigger mode here as well, 2T and 4T, and then memory settings here as well, which is really cool to have on plasma cutting because I don't always remember the best amperages for each material thickness. But now I can go in to find what I like and save it. Really freaking cool. Showing my input voltage and my plasma cutting amperage from 20 amps to 40 amps. So we're gonna do some 3/16, so let's go like 32 on that. And we'll take some stabs of that and see how it cuts. Ooh. Potato chip. Take a look at that cut. There isn't even any slag on the backside of that. That is as clean. That looks friggin' laser cut. That's ridiculous. Let's give this TIG a shot. So they seem to have supplied you everything you need here. Looks like an air-cooled torch. So the torch itself, I mean, it's okay. It's about as basic as it gets, honestly. You don't have a movable head here, so that makes, doing tricky TIG welding definitely trickier. But it's a scratch start or lift. They'll call it a lift TIG, but most of the time you're pretty much scratch starting, even these lift TIGs. And this will allow you to TIG. It is definitely not the preferable machine for TIGging, but it can be done. So it's a nice feature to have, and I'm glad that they at least include the torch, because a lot of these multi-process capable machines would charge you extra for a torch setup, even if the machine itself could do it. So that's good, but with that said, don't expect much of a torch setup here for what's included for free with the welder itself. But we're gonna fire it up and see how it does. So the accessory kit they give you with it looks pretty decent, although it is missing one critical piece, which is the tungsten. And it looks like there's a cutout here that should have had a tungsten in it, or could, but it is not included. So we'll grab one of my nicely used ones here. We'll put a fresh end on that though. And yeah, that's just strange that they wouldn't include the tungsten. I'm going to give you 3 collets here and no tungsten, so kind of a strange combo. Okay, we'll get our gun set up. We got a freshly ground down tungsten ready to go. Over the collet here, slip that guy in, slip this guy on. Throw the cap on the back just loosely for right now. And zoink. Get our stick out where we want it. I'm gonna go right about there. It's a pretty narrow cup. Snug that guy down, and we're good. I'm gonna remove the plasma cutting torch, although you can leave that in there. I'm just doing this so you can better see it. All right, connection wise, clamp is gonna be on positive. And our TIG torch will be on the negative lead here. Hit our home button, rotate down to TIG, select. And what do we got for options here? Basically just going to give you your amperage settings. So on the low end, 20 amps, and you have literal single digit control all the way up to 200, I'm guessing. Yeah, right up to 200. So because this is a very manual process with the lift TIG, you've got no button to control. This thing is energized and live when you're in this mode, and your gas flow is controlled just by a nozzle right here. So again, this will TIG, but this is by no means a TIGging machine in my opinion. It is just a machine capable of TIGging. If you really want to TIG, you want a dedicated machine with a foot pedal, variable amperage control on the foot pedal, automatic gas where you can go in and set your pre-flow and your post-flow. You want all of those features, but this does give you the option to handle some TIG tasks if you need to have it, and that's what this is. That's about all this is really designed to do. Geez, that's not too bad. Wow, I actually really like the arc. Getting a great puddle, blew right through it. Just a little heavy on the amperage there, holy moly. That thing puts out some heat. Woo. So at 140 volt, or 140 amps, we just blew clean through some 3/16. So that's pretty good. All right, so let's bump this guy down. Let's take 20 amps off it and see how it likes that. Geez, you know, I really don't mind the arc here. Man, that is, once it's lit, it's very easy to control and keep a nice stable little cone of heat. And there's absolutely nothing remarkable about the torch. I'm not really sure why it's so good at that, but I am pleasantly surprised at how controllable that is once you get the initial arc started. So we got some 1/4 inch here, and I bumped the amperage up on the machine to 160, and we'll see how it likes that. Yeah, I'm really impressed with the little cone of heat here. It's very stable and very smooth. See that little guy? Don't you worry about that little guy. I just tapped it with the torch after I was done welding, but I mean, it lays a really nice bead. Even the start, pretty clean. If you watch my channel for any length of time, you know I'm not a big fan of arc welding or stick welding. And I usually don't even bother testing that, but you and I have come so far on this particular review. Let's fire it up and give it a shot. So I've got some 60-10, I think. Yeah, some 60-10 rod here. And we'll go strike an arc with this and see how we like it. All right, so back in the menu here. And whoop, right there. Select. Very similar to the TIG menu. We can select our rod type. 60 series and 70 series. We're using 60-10, 330 seconds, and then you've got memory spots to store your favorite settings here as well. We're at 160 amps, we don't need that much. Let's dial it to let's dial 130 and see how she likes that. All right, I'm just gonna test it here, and then we'll do a bead on the other stuff. All right. Promising. Nice arc. Nice start to the arc. That started really easy. Good heat. Can't complain about that. Wow, yeah, I'll give it to him. Not bad. This entire country was built on stick welding, but man, what a messy process. Does a nice job though. Really nice smooth start, no complaints there, and no problem maintaining the arc. Great heat, good penetration. It's just a messy process, but the machine itself does really nice. Does a nice job. To recap, MIG, very nice job, just like the rest of their welders, but what sets this one apart is that screen, ease of use, and then the ability to store your favorites in a memory setting. That is a really cool feature to have. TIG, not a fan of lift TIG, honestly, but if you're gonna lift TIG, this does a really nice job. Would like to see a little bit better quality torch, but it gets the job done. Opposable head would be a really nice thing to have on there. But it's a free torch included in a machine that honestly they could charge what they're charging for if it just did MIG and plasma by itself. So the fact that it even does TIG and that it does such a nice job with that arc, very controllable, and it allows you to make mistakes and really pull your torch pretty far away before it loses that arc. So you know, I guess I really can't complain there. And it definitely lays down a nice bead, so no complaints there. And then stick welding, again, not a big fan of doing that. But very easy to ignite the arc, plenty of power, and again, you've got all of those settings that you can easily access and change and store even for that program, so that's great. Plasma cutting, without question, the best off-brand plasma cut I've seen come out of anything. The cleanest cut I have ever seen come out of a machine that is, you know, under $1,000. So that's really impressive, and it has a high voltage start, which obviously is a feature you definitely want to have on that. But like I said, just those two things, MIGging and plasma cutting, that you've paid for the machine already. But the fact that it comes with everything else you need to get going, I mean, really the only other thing you need is a tank of gas and an air compressor, and you're good to go. So as always, very impressed with them. Great job with the build quality, component selection, again, and assembly. Really, really well-built machine. And if you use that code that is in the comment section, trial and error, you save 10%. Another 10% off what is already a really value-priced machine. So not bad, pretty impressed. As always, everybody, thanks for watching. I do very much appreciate it. Any questions, comments, concerns, or criticisms, throw them down in the comment section below me. Otherwise, everybody, have a great day.